Good evening, everyone. It is once again Ted the Speed Learner, and tonight I'm going to start a three-part video series on the topic of thermal acoustics. Okay, so here we go. Before I do, though, I want to let everybody know that I published 5 Kindle books. If you're interested in any of them, you are more than welcome to leave me a comment in the comments down below. With that all out of the way, by the way, the books are $5 a piece if you want to know. There you go. With all out of the way, let's get into the topic, shall we? Basically, this is the process of converting sound waves into heat energy, but I will be a bit more technical in this particular video. Let's begin with an illustration. Have you ever played a flute? The flute is designed to take sound from your lungs and turn it into an audible music. This is done by the design of the flute. You can research this topic by reading this particular web article, and I'll leave the link down here in the description below. If you could create a flute with a PVC pipe, you can also create heat with just the sound and a PVC pipe. And I have now left a link to a video which describes this process. It's right down here below. Now, at this point, I wanted to talk about something called convection. Let's say you decide to drink some hot chocolate. So you place cold water in a kettle. When you heat the bottom of the kettle, the water at the bottom of the kettle becomes hot. The water also becomes less dense as it travels to the top of the kettle. And I'm going to illustrate this right now. Okay? Da-da-dee-dee-dee-dee. Where do those? Ah, yes, there we go. Alright, let's illustrate this, shall we? We're going to start. I'm just going to make a bowl here. Okay? We're going to make a little flame down here. Okay? Alright, let me illustrate this. Let's just suppose, hypothetically, that that's your tea kettle and that's your heat. Okay? Heat is going to rise just like this. And then your cold air is going to come from the top and go straight down to the bottom. Now, eventually, all of this is going to get heated up. But your heat's going to go up, your cold water is going to go down. Alright? Now, this is kind of the same thing if you're talking about convection with acoustics. Okay? And we'll get into that in just a second. Alright. So, that's why it takes a while for a tea kettle to produce you enough hot water to drink hot chocolate. Okay? The same effect can be observed in hot air balloons. Remember, the air inside the hot air balloon is actually warmer than the air outside of it. So what does the hot air balloon do? It rises right into the sky. Okay? So how can we use these facts to generate heat? Well, I'm going to cover that topic in part 2 and part 3 of this particular series of videos. So I'd like for you to stay tuned because there's plenty more to coming up. I will tell you more in a future video, so I'd like for you to stay tuned.